All right, I've drawn a parabola here. It happens to be a parabola that opens upward, but this property applies to any parabola independent of the direction it opens. Uh, Parabolas occur in the real world very frequently. Um, Satellite dishes for collective properties will take a signal in. They'll take a signal in at a particular angle from a satellite in space, and because of the shape of the satellite dish that's a parabola, actually in 3 dimensions a paraboloid, it will take that signal, and with the satellite in space sending it in at the correct angle, it will take that signal and direct it to the receiver in the satellite dish, which is at the focus of that satellite dish. Okay, so um, also parabolas are used as reflective surfaces like in headlights and so forth. So the reason parabolas are used in these applications is because of this geometric property. The geometric property is, well, first let me remind you of all the parts here. This is the vertex, this is the focus, and this is the directrix. There are other parts as well, but they're not so important for this particular property. The property that a parabola has is choose any point that's on the curve. And what I mean by that is, and this is the actual parabola here, right? The focus is not part of the parabola and the directrix is not part of the parabola. The vertex is part of the parabola, but the parabola is this actual curve. The focus and directrix are just there to establish this geometric property. And this property says that pick any point on the parabola. Let's say this point up here that's in blue. Pick any point on the parabola, measure the distance from that point to the focus. That distance will be the same as the distance from that point to the directrix. Now, my picture here is not great because it's hand drawn, but this distance is equal to this distance. Now, the cool thing about that is this property is true for any point on the parabola. Let's say choose this point, for example. This is another point on the parabola, on the curve. Measure the distance from that point to the focus, and from that same point to the directrix, and those two distances, those two distances are equal. So this particular property of a parabola allows it to be useful for something like collecting a signal or reflecting a light in a particular direction, like in a flashlight or a headlight. One more thing that I think is pretty obvious. Notice that when I measure my distance, in either case, from the point on the curve to the directrix, that angle is 90 degrees, right? And when I say from this point to this line, you wouldn't measure it over here, for example. You measure the shortest distance, which would be perpendicular, or 90 degrees. Okay, now, in another video, we will look at implications of this property mathematically. We already know what it means in the real world, why it's useful in the real world, but now we'll look at mathematically what sort of things happen because of this.